assessment. When you do assessment of structure, we have to assess everything, the whole structure, the element, and also the connection, and then the material. Now the element. One of the criteria is the strength. Strength means the capacity of this element, only one element, to sustain load up to the yielding here, Pmax yielding. This is strength. Stiffness is what is the relationship between load and deformation. We call it stiffness. So maybe it is strong enough, but if it is not stiff, then there will be large deformation. Yeah, when you have large deformation, it is also called failure. Yeah, and in assessment, deformation is one of the criteria that we have to assess or inspect. And then stability. It is not fail under ultimate load. It can deform, but it buckle, buckle. And the buckling we can refer to design and also analysis. I think in one of the topic we have talk about buckling. And then ductility is the ability of this member to deflect beyond the elastic zone here. This is the elastic zone, elastic point, and then it can deflect. It can deflect more and more and more without failure. Then we say this is a good structure because it is ductile. It is not a good structure if it is not ductile. For example, the case of brittle. Concrete is brittle. Metal is ductile. So we cannot use concrete for certain type of element. And then if you want to use concrete, then the concrete is to be composite with steel so that it has some properties of ductility. And now we go to material. We go to material. This is the whole structure. You go to member, and then you go to material. And this is the usual curve that we always come across, this one. The relationship between stress and also strain. We start with the elastic deformation up to the yielding strength. We call it low yield strength, and then it will elongate again at inelastic limit, which we call it ductility. So this is strength. This is strength, ultimate strength, and also yield strength. And stiffness is this portion. This portion is called stiffness or E value, Young's modulus. And ductility is this portion, based on this portion. The longer this portion, the more ductile. For concrete and other brittle material, it can just reach up to this point only. Then abrupt failure or fracture. So we call it brittle. And stability. What is stability in terms of material? Then I can say it depends on link, change link between each molecule. This is stability. If this is not stable, then we say the material is not good. The material is not suitable for the design. Okay. And when we talk about stability, there are different type of failure due to stability. Fracture or yielding. Fracture mean when it is up to the yielding point. When the stress is up to the yielding point, it is fracture or yielding. Buckling Stress is under, well under the yielding point, but it buckles